So good morning. Jantine, your presentation, I have been to many of these, was the best I've ever heard. That was a fantastic presentation for those of you who've been part of the Geospatial Mafia or part of the BIM Mafia over the years. She really highlighted what are the keys for us in the future and also gives us kind of an idea of the things in the past. So fantastic, fantastic job. Couple of points that I took away from hers that were excellent is we need to come up with the same terminology. There's about 150 people here today. I guarantee you there's 300 different definitions of BIM at least in this room. Very similar to GIS. So if people think of GIS, I'm a surveyor. Okay, so if you think of GIS 15 or 20 years ago, many people had all of these different definitions of what GIS was. And it really started as really a visualization or a digital representation of the real Earth, or what we were trying to map or what we were trying to survey. In BIM is very similar in that. As she mentioned, it was going from 2D to 3D. BIM is very similar in that aspect. Some of the key issues in GIS 15 or 20 years ago was terminology. People would say, I have GIS software. How many in this room say they have BIM software? Okay, many of you will raise your hand. Okay, but what is BIM software? Okay, there's 300 different definitions of BIM, and that's just in this room, just in Amsterdam. So I think terminology is key for us to get an idea on what that is. And then the part that she touched on, which I think is going to be key for the geospatial world and for the building world, building being both vertical as well as infrastructure, is interoperability. I think OGC brought to us a strong interoperability within the geospatial world. Building Smart is working at building a interoperability in the actual building, in the building world. So great presentation, I think gives a very good view of the industry. Our goal for all of us in this room is to build a better infrastructure. A better infrastructure that costs less, is done quicker, is safer, meets certain design requirements. And when I say infrastructure, I'm not just talking about a building being a vertical infrastructure. BIM applies to whether you're doing a bridge or whether you're doing a road or whether you're doing a railway. The initial definition of BIM did not restrict itself just to a vertical piece of construction. So many times we put it into that box, but it doesn't need to be in that box per se. You know, the key issue today, and this is on construction sites, you know, worldwide, is there's about 20% rework. Okay, we can argue whether it's 17% or it's 23%. There's about 20% rework on a construction project. And now that could be a construction project being a road, railway, airport. That could be a vertical construction being a commercial building like ourselves. It's a multi-trillion-dollar industry. So if you look at Omnica's and my numbers, they differ a little bit. I'm not including residential. So I'm just looking at just from a commercial construction perspective, multi-trillion-dollar industry. Okay, so for those of us who are in the services business, significant opportunity for us by really looking at how do we transform that construction process. Construction in general have been laggards. Okay, we have not, in the construction industry, have not adopted technology at the same rate as other industries. So other industries have allowed or have utilized technology to really improve their productivity, improve their quality. In construction, we haven't done that. In construction, we usually use scale in a different way, scale being size. bigger machines, more people, more shovels, more nails, more tools, more people. But we haven't really used technology in the past to scale. You've seen in the last 15 years the heavy civil or the infrastructure business, which is kind of moving dirt from one side of the road to the other, okay, has actually used technology more effectively than the building construction market. So you looked at Annemieka's results of BIM adoption, however we want to define BIM, 300 different ways just in this room. You know, BIM adoption has been primarily early on in the process and primarily has been done on a visualization, from a visualization perspective. So going back to Jatin's presentation is, you know, GIS was the same. The cartographer did it to do a pretty picture, okay? And those of us in the surveying industry, I don't know how many surveyors are out there, but those in the surveying industry, we all laughed at GIS 15 or 20 years ago and said, this is a cool picture, but what value does it have? It many times didn't have the rigor of the model behind it, okay? In some cases, that's the same problem that we run into with BIM, okay? So technology really is transforming kind of the building of all infrastructure. So again, not just vertical, okay? I think what I'd like us to leave from these next 2 days is don't think of BIM as just something that's vertical construction. It's really the entire construction process. And that really what BIM is. BIM isn't a piece of software, okay? BIM isn't a piece of hardware. It's really the optimization of that entire workflow. BIM isn't a model. Okay, there are standards like IFC that allow transfer, but really look at BIM as a way to really build a better city, build a better infrastructure, build a better building, okay? And through that transformation, we really look at it from a different set. There's a set of solutions and a set of enablers that allow us to get there. One is, and again, Jatin's presentation was fabulous, is she talked about the registration of deeds, okay? Okay, Holland, by the way, and I'm a surveyor, Holland is one of the leaders in the cadastral movement. There's probably 5, if 5, countries around the world that are as advanced as Holland in the cadastral area. And so, you know, just now they're starting to register things. So 15, 20 years ago, GIS took off. Now you're just seeing the registration of deeds. Where I come from in the US, we still survey very similar to George Washington, okay? Okay, we use different tools, but you know, our registration process really goes back to George Washington days. So it hasn't changed. So what she showed on the GIS side is that life cycle of solutions. That's important for us as well. On the BIM side is how do you go from the architectural phase or the conceptual phase all the way through to the build and to the maintenance. Again, that is what BIM is. That BIM is that integration and that transfer across that entire workflow. The other piece is really the constructible model is important. Okay, so let's go back to GIS in the early days. It was a pretty picture. It was a nice digital representation of whatever that physical entity was. However, in the early days of GIS, it really did not have the strength or geometry behind it. That's why all of us as surveyors laughed at it, okay? None of us as surveyors are laughing at it to now because we missed the boat, right? And we missed the boat in that as an opportunity. But it didn't have that rigor. So today, it's that constructible model that's very important for us on the BIM part, okay? Is you can create a very pretty picture of this hotel. And you can show a model of this hotel. Okay, but if I'm going to build it, I need to be able to know where every nut and bolt is within that model. Okay? I need to know its interaction today between its GIS or its surveying component or its land use. So the constructible model is a key piece. Again, open collaboration. We need to be able to share data. Interoperability was an issue. If we would have sat in a GIS conference 15 or 20 years ago, the big talk would have been interoperability. And everyone would have talked about interoperability. Today, interoperability is important. Okay? And no one in this room just has one type of software or one type of hardware. Okay? All of you have different needs, and you have different hardware and you have different software. Interoperability is key. Data interoperability cannot be a competitive advantage. GIS found that out. The explosion of GIS actually came more from taking it from a pretty picture to allowing to do analytics on it. Okay? So Jatin was showing that from an analytics perspective. Analytics allowed us to use that pretty picture. It also had the rigor of a constructible model, or in that case, a geodetic reference, right, from a GIS perspective. But the other piece was interoperability. You had to share data. You had to share data between forestry, and you had to share data between cadastral systems, and we had to share data between the surveyor. So interoperability was key. All of that really equals a transformation in our perspective. That is going to allow us to build a better building. Things that enable that is content. So just like in GIS, content, you got all this map data from different sources. How do you deal with it? We have that same issue in a building or a piece of infrastructure. Domain knowledge. Never, never dismiss that. So we as surveyors had to be involved with the GIS movement because we needed to provide that geodetic rigor to that model. We need building professionals, whether that be architects, whether that be designers, whether that be MEP professionals, whoever that is, you need that domain knowledge to really build that better piece of infrastructure. Services. Those of you from the services side of the business, services are key for the delivery of these solutions. And then you all need partners. Partners, we talk about interoperability of data, but you also need interoperability from a partnership perspective, whether that be Delft with the government or Delft with a certain contractor. Our whole goal is, how do we reduce that total cost of occupancy? Now, this is a very vertical piece, but that's why we build a building. Okay, how do we reduce that cost? How do we allow designs to be realized, and more complex designs and more visually appealing type of designs to be looked at? Okay, today there are complex designs worldwide. Take the Bird's Nest in Beijing, right? Take the Gherkin building in the UK. Okay, you take these different designs, take the Qatar National Museum in Doha. You look at these fabulous designs, could never, ever, ever, ever be done without technology. Okay. Technology has allowed us to realize a much different type of design. And then most importantly is, if you're an owner, okay, if you own that piece of infrastructure, whether it be a government entity or an owner, it really reduces that cost and improves that productivity. This is just to give you an idea, again, is BIM is not restricted to a vertical building. Okay? And by the way, for all of us who come from the vertical construction perspective, we're not light years ahead. Okay? Jatin showed they've crossed that path from a geospatial 15 or 20 years ago, so that's learned from that. The heavy civil or the infrastructure market has been doing this for the last 15 years. They just didn't call it BIM. Okay, so us 150 people in this room may want to feel special, and we may be special in some ways, but we're not special in revolutionizing this. Okay? GIS and surveying has done this 20 or 25 years ago. Heavy civil business has been doing it for the last 10 or 15 years. So we must learn from what has been done in these other industries. And the keys are interoperability, right, and rigor in the model. Those are the two keys that exploded both GIS as well as the infrastructure business. This is kind of an adaptation off a McGraw-Hill study. It's very US-based, though I think it applies worldwide. But it gives you an idea on, again, depending on what definition of BIM you pick, because this was done as a survey, so 300 different definitions just in this room, here is where BIM has been adopted, okay? And then where does the contractor see value, okay? So it's been adopted very early on in the process. Annika mentioned that in her presentation, that showed, you know, the architectural groups, really our architectural field or the design field has adopted that first, okay? And that's where and they've adopted it from a visualization perspective. They've adopted it from a clash perspective, but it has not been adopted that much in the field. What we have found is, and Annika showed this in one of her examples, is when you bring that digital representation and you bring it out into the field, like you do on a machine, and you can then push dirt from one side of the road to the other, and you can do it much more efficiently. And as you push dirt from one side of the road to the other, that data can go back as a real-time as-built, and that model then becomes dynamic. Really, even from a GIS perspective, we're not there yet from a dynamic modeling. Okay, so if in this room we want to be special and be ahead of GIS or ahead of the heavy civil business or the infrastructure business, maybe we should look at a dynamic BIM. Okay? So then we have a whole new set of definitions that we can come up with. But you know, what about a dynamic model that as I hang that drywall, okay, and I use that tool or whatever, and I hang that drywall, and I'm continually then updating that model. Okay, so then you as an owner can visually look at that, and you can also predict and run scenarios or run analytics on it. My thing has, technology is always wonderful in these kind of things because sometimes it works, sometimes it doesn't. But just like GIS, just like BIM, yeah? So the key is, you know, we have a model, both from an infrastructure business, so take a look at infrastructure on the left-hand side, that's pushing dirt from one side of the road to the other, and then on the right-hand side being a building, okay? We need to look at this as an entire process. Okay, we can't look at this from architects, we cannot look at this from a plumbing perspective, we cannot look at this from a general contractor. We need to look at this as an integrated model, as an integrated process. That's how we're going to get the efficiencies that you see in some of the projects that have happened so far. It goes back again to Jatin's presentation of how do you take that integrated cadastre system and go from actually a 2D representation to a 3D representation to an electronic deed, okay? This is what we're trying to do here. On the left-hand side, this is very commonplace. Okay? You're seeing major infrastructure projects around the world utilizing this entire process where they go from concept all the way into moving dirt from one side of the road to the other and back. Okay? On the right-hand side, we're still looking at. If you look at the bottom, someday we will have an intelligent tool. Just like we have an intelligent machine that has the model, someday we will have a tool where that tool will have the model within it. That's no surprise. We will definitely get to that stage. Sorry, guys. Our key now is how do we combine those two models? So, as which was talked about previously is you have the GIS world, okay, or the GIS model, let's call it, and then you have a vertical construction model, but you also have a site model. So it's really merging of three different models. You have the GIS, which has a basic land structure to it. It has a set of attributes. You have a site model or a heavy civil or infrastructure model, which is a set of tangents and curves. It's a DTM associated with that piece of infrastructure. Then you have the building. Okay? This is the holy grail. Okay? I'm sure there's multiple marketing propaganda from all of us, Trimble included, that says this exists, okay? But today, nowhere does it exist to allow the integration we actually need to get to that integrated cadastre that we just heard about in Jatin's presentation. That's our focus, is how do we have interoperability between the GIS, the vertical world, and the infrastructure world. So I apologize, my clicker is not responding as well. So the goal for us is how do we re-engineer this whole process? And we engineer this whole process from going from the conceptual stage, right? So the conceptual stage is where we start, okay? And today that's the architectural piece, into the engineering design, to some type of estimating, okay? Into project planning, to construction, to actually hand over and the logistics associated with it. I think my clicker, guys, is running out of power. Couple quick examples here before I close up. Here's a real-life study. So this is building a road with and without type of technology and without using the process. The key is it got done quicker. Okay, so it got done significantly quicker and with less rework. And from a sustainability perspective, it got done with more fuel savings. So technology allowed this road to be built with and without technology much quicker. In a building case, Trimble just built a new campus. And so, of course, we used all Trimble junk on the campus so we could see, okay, how could you use it? And what we have found was it really gave us the productivity advantages that we, as well as others in the industry, talked about. Okay? However, we as the owner said, you must use it. Okay? So the owner is going to be the biggest driver in this actual technology. Okay? So in the previous example of the roads, okay, or transportation entities worldwide are now saying, use technology. I don't care what kind of technology you use, but use technology in this integrated approach because it's going to build a better road. It's going to build a road quicker. It's going to build a road that's higher quality. It's going to build a road with greater safety. Okay? Tons of results. I showed you one back there of a study, but there's significant amount of results to do that. In the buildings, there's less so. Because again, the adoption has been more on the front end or the conceptual side of the business, not through the entire integration process. So it's us here to better educate owners to utilize this technology to really show them what the benefit is. But we saw significant benefit. We got this project done on time. We got this project done under cost. We had significant savings. Okay, and I just don't say that from a Trimble propaganda perspective. You know, there's data and we've seen it. And if you used others in the industry in similar types of buildings, I'd expect the exact same results. So it's us in this room that really need to drive this process. So I appreciate your time. You know, the next 2 days, I think our goal is, you know, let's try to get 300 definitions of BIM down to 20 or 30 at least. And let's work on interoperability. I think that's key. And that remember that BIM, just like GIS, is not just one part of the workflow. It's the entire workflow. Thank you very much.
Thank you very much.